Hello everyone. Today we will discuss about the important topic in the course of the hydrology and water resource engineering. The today's topic is transpiration and evaporation. In the previous session, we discussed about the evaporation and types of the evaporation and evaporation pan. Different type of the evaporating pans can be discussed in my previous lecture. In this lecture, we will discuss about the transpiration and Evapor Transpiration. So that is the today's topic. And my name is R. Suresh Kumar, Assistant Professor in IARE Dundigal, Hyderabad. So evaporation, before going to the small definition, is evaporation. As of course everybody knows, the evaporation is the air molecules, the water to the air from the source as the soil canopy, interception, and the water bodies. Water is evaporated from this one, we call it as evaporation. And transpiration, basically the transpiration is nothing but the movement of the water within the plants and the subsequent loss of the water as vapor through the stomata of the leaves. That's why we call it as transpiration. Next, in the transpiration, we discussed about transpiration. So the plant and leaves, the above the plants and leaves, the evaporation from the leaves through the small holes inside the leaves, we call it as in the technical term as stomata in the leaf. So in this inside the small water can be stagnated in that one, and this can be sometimes referred to as dry leaf evaporation also. We call it as dry leaf evaporation. And besides of this water cycle as the source of the water vapor in the atmosphere. So that is the transpiration of the one of the points. In the transpiration, next point, it serves as the multiple functions. So what are they? The plants itself, it provides the transport the various elements from the soil through the different parts of the plants, and also regulates the heat when we reduces. That is the main function of the transpiration. So the quantity of the water transpired, how it can be affected. So by plants depends upon the meteorological factors and the soil moisture content and the root zone. So and also age of the specific plants and development of the stage of the folic and depth of the roots. That is the main, the quality of the water can be depends. The quantity of the water transpired also depends upon the some physical and physiological factors related to the plant. Each of the contains different type of the plants can be absorbing capacity and physical characteristics, and physiological factors also different. That's why each of them separately we have to quantity of the water can be transpirated. So what is meant by transpiration ratio? In the transpiration ratio, what we called as the ratio of the weight of the water absorbed and conveyed through the transpired from the plant during the growing season. So the entire growing season, what is the root zone? The weight of the water can be absorbed by the growing up period. So and also weight of the dry matter produce the exclusive of the roots. So that's why actually the transpiration ratio is equal to weight of the water transferred divided by weight of the dry matter produced. That is the transpiration ratio. In the transpiration ratio is the very important. Weight of the water can be transferred from the leaves and weight of the water dry matter produced inside. So we call it as transpiration ratio. This is one of the very important definition. Next, what are the factors affecting on? Is there any factors affecting on the transpiration? So let us see the temperature. In the temperature affect the in the kinetic moment energy of the molecules, they diffuse the faster evaporation due to temperature increases. Automatically, it is also increases. Next, air movement of the wind. What is the effect of the air movement of the wind in this transpiration? So the removes the water molecules that they pass out the leaf. So to maintain the water which is the above the plants can be steep, concentrated, gradient or diffusion. Gradient and diffusion. These are the different type of the air movement of the wind or wind movement of the water throughout the air atmospheric conditions, and it can be affected in the leaves. Next, humidity. How the humidity can be affected in the third one. Humidity is the concentration of the water molecules in the atmospheric conditions and outside the leaf. So whatever the surrounds of the leaf, steeper concentration gradient for the diffusion. That is the main of the humidity. Next, light intensity. What is meant by light intensity? In the light intensity means the effect of the light in the above the plants of the list, the tomato, what we previously, the inside the small holes in the leaves are open to allow the gas exchange for the photosynthesis. So water vapor can be diffused out of the leaves. So this is the 4 points of the general important points of the factors affecting the transpiration rate. So first one is temperature, next one is air movement, next humidity and light intensity. These are the 4 types of the factors can be affected in the transpiration. So various methods can be applied for the measurement of the transpiration. One of the widely used of the method is the phytometer. Is the one of the best thing for calculating the transpiration. So in the transpiration calculation, phytometer consists of a closed water-tight tank with sufficient soil plant growth, with only plant can be exposed in the outside. So water is applied artificially to that plant's growth completely. So the after some time it can be how can be evaporated can be measured by using the phytometer. By using the phytometer, we are calculating the transpiration value also. So next, quickly move on to the evapor transpiration. This is the very important topic in the evaporation uh, in the evaporation topic. So evaporation, as we know very well, we already discussed. Transpiration is also discussed. And what is meant by evapotranspiration? So evapotranspiration in the denoted by ET is the sum of the evaporation and the plant's transpiration from the earth, land and ocean surface of the evapotranspiration normally. Here we can see here the plants can be which is evaporated here, and the grass and also plants, trees. So the transpiration, and also which is the runoff, which is the water from the ponds and lakes, also evaporation. So evapor transpiration is nothing but simply we call it as evaporation from the plants and trees, as well as evaporation from the surface of the ground and atmosphere. We call it as evapotranspiration. Evapotranspiration mixed of the evaporation as well as evapotranspiration also. We call it as evapotranspiration. Evapotranspiration is some of the evaporation as the plant transpiration from the land, ocean surface, as we already discussed. So the time unit can be an hour, a day or decade, month, hour. Entire growing of the period of the year can be calculated by evapotranspiration. The rate of express the amount of the water lost from the cropped surface of the units of the water depth. So from this one, what we have to learn actually, the atmospheric the atmosphere evaporation accounts for the movement of the water to the air and from the sources of the soil and canopy interception and water. So this is the evapotranspiration can be simply in the meaning. So why we have to evaporation can be evapotranspiration only. So evaporation from the ground as well as evaporation from the leaves can be entirely the total area can be evaporation. How the by using the any of the hydrological calculations and precipitation can be evaporation and transpiration, evapotranspiration. These three are the very important factors while the calculation of the precipitations. So is there any types of the evapotranspiration? Yes, there are the two types of the evapotranspiration. The first one is potential evaporation and the second one is actual evaporation. These are the two types of the evapotranspirations. First one is potential and second one is actual evapotranspiration. Let us see one by one. What is meant by potential evaporation? So, what is meant by evapotranspiration, actual evapotranspiration? Let us see one by one. In the potential evaporation is the measure of ability of the atmosphere to remove the water from the surface, through the process of the evaporation and transpiration, assuming no control on water supply, is called potential evaporation. I repeat once again, potential evaporation is measured of the ability of the atmosphere to remove the water from the source through the process of the evaporation and transpiration, assuming no control of the water can be supplied. So this is called the potential evaporation. But what is meant by actual evaporation? Actual evaporation is nothing but the quantity of the water that is actually removed from the surface due to the process of the evaporation and transpiration is called actual evaporation. See the difference between these two, potential evaporation and actual evaporation. A small thing you have to be remembered here. Ability of the water to atmosphere to remove the water from the surface. So here is not that the quantity of the water, how much the quantity of the can be removed from the surface due to the process of the evaporation and transpiration is called actual evaporation. That is the difference between the potential evaporation and actual evaporation. Let us see regarding this evapotranspiration. You should have to know some of the definitions before going to the topics. So, evaporation, as we know very well, the transformation of the water from liquid to gas phases. It moves from the groundwater, moves the ground or water bodies into the atmosphere. Can be we call it as the evaporation. And what is meant by transpiration? The transpiration is nothing but the water vapor from the plants into the atmosphere. Simply we call it as transpiration. Next, condensation. The condensation means the third one is the transformation of the water vapor to the liquid water droplets into the air, creating the clouds and fog is called condensation. I repeat once again, in the condensation is nothing but the transformation of the water vapor in the liquid droplets into the air is called. So it means the water which is the atmospheric conditions, humidity conditions is there. So there some of the atmosphere is there. Especially in the coastal region, there is a lot of humidity in the air. So that is in the dry region there is a liquid drop particles will be the less in the dry air. So that's why there is the transformation of the water vapor, liquid vapor droplets to air is called condensation, creating the clouds and fog. Next, precipitation. Condensation water vapor that falls into the earth surface is called precipitation. So as we know very well, the broad precipitation, water which is the falls into the ground, different type of the precipitation. Why we call it precipitation? We discussed in the first topics and first videos. So what is meant by precipitation and the types of the precipitation and forms of the precipitation, why we have called it as precipitation will be discussed in the previous lectures. So that's why we have to know the why we have, again we can recollect the this one. Why toward the evapotranspiration it can be also incorporated this one. That's why we have to know some of the definitions how the evapotranspiration can be transforms. Next, this is a water cycle. Of course, it's already water cycle or hydrological cycle. Means the why we are showing this pic here once again means here also the evaporation to show the condensation, transpiration and precipitation, evaporation from the oceans and sea. So this one evaporation from the oceans, transpiration from the lands. That's why we call it as evapotranspiration. We call it as evapotranspiration. So that's why I have to show in this one. Once again, I collect this pic from the previous one. So, what are the factors affecting on the evapotranspiration? So, in the previous one, we discussed about the what are the factors affecting on the transpiration. Here, not evapotranspiration. Some of the factors can be affected. So, what are they? The first one is environmental factors. Second one is plant and crop factors and geological factors, and fourth one is soil factor. There are the four factors are affecting the evapotranspiration. So, environmental effect. What is the environmental effect? Is the temperature, humidity, wind speed, and the color of the surface, albedo, and water available. These are the all five factors can be affected in the evapotranspiration. So, in the an environmental effect, it can be affected. All are can be affected in environmental effects. So in the environmental effects, the first one, let us see from the top. We comes from the temperature. The temperature, the warm is more evapotranspiration, as we know very well. So in the hot temperature, the evaporation from the ground, from the atmosphere, and also from the leaves and plants, the evaporation will be automatically increases due to effect of the temperature. It is directly proportional, means it increases automatically. The evapotranspiration is also increases. That is the temperature. Next to humidity, how the environmental effects, the humidity can be affected. The humidity can be affected. Higher humidity means low evapotranspiration. Yeah, this one is as we discussed in the previous one. In the humidity of the air inside that one, if it is humidity will be increases, the evaporation as well as with continued transpiration, evapotranspiration will be all or can be decreases. Why? Because this already itself as a humidity in this air molecules, so the evaporation will be there, very slow when compared with the temperature and relative humidity means it can be higher humidity means lower evapotranspiration. It means inversely proportional to the humidity. We can think like that. So previous one is directly proportional. So in the second one is inversely proportional. Why I called it as inversely proportional means the humidity increases, humidity increases, the evapotranspiration will be the decreases. So that is the effect of the humidity in the evapotranspiration. Next, wind speed. In the wind speed, how it can be affected? In the previous one, what we discussed, the more is in the speed, more evapotranspiration means in the effect of the wind in the above of the leaves and the atmosphere, it can be automatically can be taken the atmospheric in the valley in the water vapors can be transferred from one side to another side to the effect of the uh, air can be increases automatically. The some water particles also can be collected and transformed to one to another due to effect of the wind also. So this is also the directly proportional. Why I call it as wind speed increases, evapotranspiration is also increases. So you should have to remember like that. Next, color of the surface of the albedo. So how the color of the surface can be affected? The lighter colors of the reflected uh, heat away from, so there is a less evaporation. Of course, in the summer we wear the white. Why? White means it absorbs the radiation and cannot be transferred when compared to the thick colors. So that is the light color. Light colors of the reflect the heat from the radiations from the atmosphere, or light can be reflected solar radiations. So there is a less evapotranspiration. So last one is water available. Less water means less evapotranspiration. So automatically less water means water availability is less. Automatically the evapotranspiration is automatically decreases. Means it also can be directly proportional means. So there the water is not available. The evaporation and evapotranspiration is no talking at all. So that's why the water can be affected. The availability of the water in the runoff can be also the major role for this one. So that's why you have the water availability. Water means evaporation increases due to availability of the water. So these are all the 5 effects of the environmental factors. Uh, Next, physical attributes of the plants. So what are the physical attributes of the plants in the vegetation cover, leaf area index, leaf shape and size, type of the plant, and stomatal resurgence. So in this one, what happens in the plant's vegetation cover? The vegetation cover means the land which is not used and can be cultivated, or any grass or plants can be all are spread over the ground. We call it as vegetative cover. So the leaf area of the index. The leaf area of the index means here the area of the leaf sizes can be affected. So how much area it can be spread over the entire area. So next, leaf size and shape. How it can be leaf size and shape can be, some of the leaves can be a small size, and some of can be a bigger size. So lot of area is also be affected in the evapotranspiration. Size will be less, will be the less evapotranspiration. Next, plant type. Next, type of the plant and stomatal resistance. How it can be affected? The plants is generally in this areas transpiration through the adjustment of the small openings in the leaves called stomata. As we discussed in the previous slides, the inside the leaf areas, small openings can be provided. In we call it as in the technically stomata. So as stomata of this closed, the resistance of the leaf to loss of the water vapor increases. It is increases what means it decreases diffusion of the water vapor plant to the atmosphere. Means the hole can be closed. That above the plants on the water can vapor can be evaporated easily. That is the main concept of this one. Evapotranspiration. What is the geological factor? Geological factors can be affected in the evapotranspiration. Geological factors. Evapotranspiration rates are also depends upon the geography, area, latitude, and the climatic conditions. The climatic conditions as discussed, as the increases the climatic and the temperature, whatever it is. So how the evaporation also depends upon the geographical means the types of the soils. That depends upon the area. It is rough or very smooth and loose soil, sandy soil, like that. Rocky area. So automatically it can be also different, depends upon the evaporation, and the transpiration can be increases automatically. The runoff, the water, the rocky, suppose it is runoff or rocky area, automatically the runoff will be increased, and evaporation, the storage of the water, due to the storage of the water, so it can be also increases the evaporation and as well as the transpirations. Next, a region of the globe where the most solar radiations, as we discussed about solars, experience the more evapotranspiration. Next, evapotranspiration rates are also highest in the areas with the hot and dry climate. Why? Because as we know very well, the highest areas will be the hot and dry climate. So the dry climate areas is automatically evapotranspiration also high. Next, evaporation is less in the higher altitude. Here, evaporation means less high altitude means in the increasing the top or hilly areas. What happens? Due to the effect of the wind effect, what happens? The evaporation is less due to cold conditions. Here, the in the going to the top of the position. So what happens? The air molecules will be automatically, the hot vapors will be also cool in the top position. Again, it can be formed as the precipitation. We know very well. So already studied in the previous. So that's why the evaporation is also less in the higher altitude. That one. Plant crop factors, physical attribute of plants, vegetation cover, leaf already. So next, evapotranspiration is the diagram is given. Evapotranspiration, how it can be evaporation from the soil, transpiration from the grass and leaves can be forms of the evaporation and transpiration. By showing the details for better understanding this one. Stomatical resistance means the plants of regulates the transpiration through the adjustment of the small openings of the leaves of stomata, as we know very well. The stomata close and resistance of the leaves to loss of the water vapor increases, decreasing the diffusion of the water vapor and plant to the atmosphere is the stomatoresistance. So soil factors, how the soil factors can be affected? The soil characteristics, soil capillary and water table depth, soil moisture. When the soil is lacking the moisture, plants being the transferred less water in the effort of the survive of the storm of the decrease the evapotranspiration. So as per the we know about the soil condition, different type of the soils. Some of the soils are absorbed and means the infiltration capacity and percolation will be the more. Some of the soils are also not infiltration capacity is less due to the soil conditions of the. So these soil conditions can be affected to the water table, and the soil moisture is also affected in the evapotranspiration. So next, measurement of evapotranspiration. So measurement of evapotranspiration, how to measure the evapotranspiration? Is there any methods to calculating the evapotranspiration? Yes, one direct indirect method and second one is direct method. So in the direct indirect method, there is the two methods is there, the catchment water balance and energy balance, and direct method lysimeter method. Lysimeter method. These are the types of measurement of the evaporation. First one is indirect method, second one is direct method. In the indirect method, the catchment water balance and energy balance and lysimeter method. So like that, these are the measurement of the evaporation, estimation of evapotranspiration. They are the evapotranspiration. Indirect method. The catchment of the water balance. Here the evaporation, see the water balance, see the first one. Catchment of the water balance, evapotranspiration may be estimated by using the water balance method. So what are the evapotranspiration? Here ET, evapotranspiration is equal to P minus delta S minus Q minus T. From this formula, we have to find out the catchment water balance. Catchment water balance. In the catchment water balance, what happens? Here, let us see the denotation. So here, ET is equal to evapotranspiration and P is equal to precipitation, and delta S is equal to change in the storage, where Q is equal to stream flow and D is equal to groundwater recharge. So D is equal to groundwater recharge. Next, energy balance method. In the energy balance method, the actual evapotranspiration is estimated by energy balance. Here, the lambda E is equal to Rn minus G minus H. Here, lambda is equal to the energy needed to change the phase of the water of the liquid gas, Here Rn is equal to net radiation, G is equal to soil heat flux, and He is equal to sensible heat flux. So these are the, by applying this formula, you have to find the energy balance method, evapotranspiration of the direct method. So in the indirect method. So in the direct method, what happens? Lysimeter method. The lysimeter method is the also one of the good technique for calculating the evaporation transpiration. In the previous one, why we call it as indirect method means they are some applying some empirical equations. From the equations only we will find out the evapotranspiration. But here we can be calculated by lysimeter is the direct method to calculating the evapotranspiration. So lysimeter is the best method to calculate evapotranspiration. The lysimeter is a device to measure the amount of actual evapotranspiration which is released to the by plants and crops and trees. So the amount of the precipitation area receives the amount, and through the soil it can be evapotranspiration can be calculated. So direct method can be is that field can be tested by applying the water how much and how much it can be infiltrated for growing of the entire crop. What we are going to be requirement of the water on certain crop. So the construction data, see the first construction details. In the construction details, select a piece of the ground and flex rain gauge of measuring the precipitation value in the millimeters, and remove the turf and grasses from the small piece of the land near the rain gauge dug of the soil. This is the all given the explanation regarding the how to prepare the ground for the doing this experiment of the evapotranspiration. Next, tank is the fixed the such way that 1 centimeter and remains outside the ground. So surface of the fill to the tank with the soil. So how it can be, I will showing the one of the pic for the regarding this how to construct the evapotranspiration by lysimeter method. So lysimeter, this is the can be here rain gauge can be provided, and it can be nearby rain gauge how it can be collected from the tank. It inside the ground can be collected, and receiver can be also inside them. So from this one we have to see the another pic for clarity regarding the see. This is the lysimeter, which is the field project can be take it as for the evapotranspiration. So here see the crop will be provided here. So from this equipment lysimeter, what we have to find? So by applying the water from the continuous from the top, so how much of the water can be actually consumed? How much water can be actually growing period, entire growing period of the crop? So and also we'll find out the how the water can be utilized. So regarding all this experiment and research, what we have to find is actually some of the crops can be required some of the water depth. So in the water depth, from this water depth, we can have the research. We will find out the actual depth of the water required on particular crop. So that can be known by this experiment of the. And not only that, evapotranspiration can be how it can be evapotranspiration can be on the vegetation cover on the given the catchment area is also the find out from this lysimeter direct method experiment. Select how the construction of this method. Select a piece of the ground and fix the rain gauge measuring the precipitation value, and remove the turf or grasses, and the tank is fixed that is 1 centimeter remains outside the ground. This one 1 centimeter and it can be already grown. So actually we have to provide 1 centimeter about the ground, and next the ground surface and fill the tank with soil, and the upper surface of the tank is filled with surf or grasses and not to be seen. The cover with graves and small stones can be polythene sheets can be provided. So next the receiver is the best. The receiver what this is the receiver can be received the how much the water can be consumed from this one. So they receive the best place for the top 5 centimeters above the ground surface of the water cannot be entered. So next, the peak soil around the apparatus and relay the turf, apply the water bed, and turf settled in the soil, construction can be completed. Next, measurement can be began in the few days. So your experiment may be continuous for the few months or every for a year, can be continuously how the growing of the plants, and evapotranspiration can be measured by this equipment. In this dry season, add water and experimental area, but the precipitation rate sufficient, no need of the water. Evapotranspiration can be, actually we know, water added minus percolated water. It means how much water can be added for the uncertain growing of the plant or trees minus percolated water, or can be inside the water after the infiltration, how the water can be percolated inside through the tangential is the evapotranspiration calculation. That is the small we estimating of the evapotranspiration. Another method is also Whitney cradle method. Whitney cradle method is the Whitney cradle method. Bentley cradle method is the development of the simple method to estimation evaporation can be assumed. Here, evapotranspiration can be closely current by means of monthly evaporation can be daily lights, daylights can be also hour, how much hours can be calculated. The monthly concept of the factor is defined F is equal to P into Tm by 100. Here Tm is the monthly mean temperature per degrees of Fahrenheit. P is the monthly daylight hours, how much light of the water for total for morning to light fail starting to evening, how much water, how much the daylight can be hours for each and every day can be noted, hour spaces, and it can be converted in the year for the inches. Next, P is the possible sunshine hours particular month into 100 by possible sunshine hours for the whole area. So next, another one, possible sunshine hours in the particular month into 100 by 365 into 12 hours. Generally why? Because we are using the 12 hours means daylight is 12 hours. From the, we are calculating from the 6 to 6. Assume it as. So maybe it changes according to the seasonally. That's why the value of the P depends upon the latitude of the place and the month of the year. That is the very important. Next, Pinmines method is another method is there for calculating the evapotranspiration. Is a small one for shorter period necessary to use the calculation of the methods for estimation of evapotranspiration. And this can be also Penman's method. The Penman's equation is the equation combination of energy balance and wind transfer approach, which leads to PET, potential evapotranspiration, is equal to A into HCN plus EA into sigma by gamma by A plus gamma. Next, let us expand this all the values. PET means daily potential evaporation. A is equal to slope of the saturated pressure and the temperature curves of the means of the air and temperature. HCN is equal to net income solar radiation mm per day. Next, EA is equal to parameter including in the wind velocity and saturated deflected and pycnometric constant. So these are the some of the methods we are calculating, the direct method and also indirect method. So from this session we have learned that what is meant by transpiration and evapotranspiration and factors affecting of the transpiration, and also factors affecting the evapotranspiration, direct method, indirect methods, some of the empirical formulas, and also effect of lysimeter. From this, applying the direct method lysimeter, how we have to calculate the evapotranspiration by applying the methods, and brittle cradle method and the pycnometer method and the Penman's method is also some of the methods will be discussed regarding the evapotranspiration. So thank you for all. For So we will end this session here. Thank you once again to all.
Like, share, and subscribe. Hit the bell icon for more updates.